Hello, hello. I am Mrs. Hickman, and today I'm going to be going over the unit circle, okay? And we might do some graphing trig, but that might be in another video, okay? So let's go. Very, very important, by the way, to know the unit circle. You're going to see it in pre-calculus and calculus, and it's just going to keep appearing everywhere, so might as well just get it in your head now so you don't have to rememorize it all the time, okay? So, super important tool for you to use. Use this time in calculus to focus on calculus. Do not use your time in calculus to try to remember the unit circle. Okay? Alright, so here we go. Okay. Get my orientation. There we go. Alright, so very first thing you want to know about the unit circle is there are things such as reference angles. Okay? So reference angle for an angle theta written theta prime is the positive acute angle made by the terminal side of an angle. Okay, so it just goes around this way. Okay. So I'm going to do these in degrees and radians. Okay, so let's just do degrees. Okay, so this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. Okay, and then once around a circle is 360. Okay. By the way, mathematical thought: if you decide to turn yourself around one time in life, please say I made a 180, not a 360, because a 360 just means you didn't change anything. Okay, you just went in a circle and you're back to where you were. So, wow, I did a 180. I changed my life. That's right. If you say, wow, I did a 360 and I changed my life, you didn't change your life, it's the same. Okay? So, anyway, reality lesson of the day. Okay? Alright, so reference angles. So, these are your prime angles. Okay? And we'll be getting to the angles shortly. Okay? So, these are going to be your standard in here. So, how to get a quadrant 2 angle, this is going to be 180 minus your theta prime. So this is going to be 180 minus your theta prime. Okay, so if this was 30, to find the angle that's like symmetric with 30, we will get to that later, don't worry. You will do 180 minus 30 will give you that angle. Okay, for quadrant 3, you're going to add 180 to your theta prime angle. And then for quadrant 4, you're going to subtract from 360. I guess I should be putting degrees. Okay, excuse me. Okay, so that's in degrees, radians, which is going to be what you're going to be using. So this is 0 radians. This is pi over 2 radians. This is going to be pi radians. This is 3 pi over 2. And this is 2 pi down here. Okay, these are your prime angles. So with radians, same thing except you're using a different symbol. So this is going to be pi, which is equivalent to 180, minus theta prime. This is going to be pi, yes, plus theta prime. And this is going to be 2 pi minus theta prime. Okay, that's how you get those angles. Okay, anything over 360 or 2 pi, just subtract. And if you get a negative angle, oh, also I need to tell you this: negative angles just mean you're going clockwise. Okay, positive angles go counterclockwise. Okay, so negative angles go clockwise. And positive angles go counter clockwise. Okay, rule of thumb. Okay, so now we are in angles of the unit circle. Okay, all right, so I guess I don't know why I got that big space. It's there for some reason. But right now, I don't know. Okay, just give me 1 second. My battery's getting low. I know you're super excited to learn how to do the unit circle. Just give me a second. All right. Okay, we are powered on. All right, so the four corners of the unit circle we already went over. Okay, so this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Yes, I know they are not corners. It's just a terminology to help you understand, okay? And this is 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi, okay? So four corners, they never change. So let's look at 30 degrees or pi over 6 angles, okay? Pi over 6, because if you were to convert 30 to radians, that's what you will get, okay? So just so you believe me, 30 degrees, yeah, 30, okay, so we're doing 30 times pi over 180, so that's going to give us 30 pi over 180, okay? So 10, they both go into 3, so you get pi over 6, okay? Or you could say 118 divided by 3 is 6, okay? Alright, so one thing about the unit circle, angles are symmetric about the x and the y axis, okay? So 30 is going to be about here. Well, probably a little bit further down. As long as it's not in the middle, it'll be okay. Okay, that's approximately 30 degrees, okay? I will never brag on my artwork, but there you go, okay? So, to do these, you're going to use reference angles to determine the degrees of the other quadrants, okay? Radians to be determined by multiplying by pi over 180, or a better way. So, every 30 degree angle is going to have a denominator of 6, okay? So, and you're always going to have a pi. So you're just looking for the coefficient in front of pi. So this one right here, so we got 30 degrees and pi over 6. Okay, so we'll do radians and degrees here. So when we get over here, you're going to do reference angle 180 minus 30 degrees is 150 degrees, okay? 150 degrees. Okay? We'll do degrees first and then go around back to radians. Okay? Here, that's going to be 180 plus 30 degrees. 180 degrees plus 30 degrees, which is going to be 18 plus 3 is 21. Okay? So that's going to be 210 degrees. Okay? And then 360 minus 30 is going to be 330 degrees. Okay? So those are all your degree angles for 30. Okay, it's getting a little blurry. Let me see if I can focus in a little bit. Okay? So to find radians, what I do, if you look here, so if you do 15 over 30 is 5. Okay, so again, every single radian for 30 is going to be something pi over 6. So you have something pi over 6, something pi over 6, and something pi over 6. So all you're doing is you're essentially just doing 150 over 30, which is 5, or you could just do, since it reduces down 0 anyway, let me get closer so you can see that. 15 divided by 3 is 5, okay? So 5 is going to go right here, okay? Now you got this, so you got 210 divided by 30, or you can do 21 divided by 3 is 7, okay? Over here, you could either do 330 divided by 30, or you could go ahead and divide by 10. You could do 33 divided by 3 is going to be 11. Okay? So these are all 30, so the degrees are all being divided by 30, okay? And see if you take out the 0, 15 divided by 3, 210 divided by 3, and 330 divided by 3, okay? Okay, so now we're on 60. Okay, 60 is up this way, all symmetric. Okay, so this is 60 degrees. This is going to be 180 minus 60. That's going to give you 120 degrees. This is going to be 180 plus 60, which is going to be 240. And this is going to be 360 minus 60, which is 300. Okay? So how you're going to find radians is pretty much the same concept as a 30 degrees, except when you're dividing all of these, you're going to be divided by 60. Okay, so another thing about 60, the denominator is always going to be 3. Okay, so it's going to be something times pi over 3, okay? So you got pi over 3, pi over 3, pi over 3, and pi over 3. Okay? So, like this, even here, you're dividing everything by 60. So 60 divided by 60 is 1, okay? If you go ahead and take out the 0, you're doing 6 divided by 6 is 1, okay? So 120 divided by 60, or 12 divided by 6 is 2. 240 divided by 60, or you could say 24 divided by 6 is 4. 300 divided by 60, or better yet, 30 divided by what? Yes, 6. 30 divided by 6 is 5. Okay, so again, this is all you're doing. So here's quadrant 2, here's quadrant 3, and there's quadrant 4. Okay, all the 60s have a denominator of 3. Radians always have pi on top, so you're just looking for the coefficient in front of the pi. Okay, or you can do it the old-fashioned way, multiply by all the degrees by pi over 180. Okay, which I think takes longer, but if you float your boat, float your boat. All right. 45 is going to be next. Okay, 45 is in the middle. It's between 0 and 90. So 45 is here. Again, everything is symmetric about the y and the x-axis. Okay. So this is 45. If you can remember your reference angles, this is going to be 180 minus 45, which is going to be 135. Okay. Over here, that's going to be 180 plus 45, which is going to be 225. Okay. And over here, that's going to be 360 minus 45, which is going to be 315. Okay. So 45s, so think of 4. All the 45s are going to be pi over 4. Okay, so you got pi over 4, pi over 4, pi over 4, and pi over 4. Okay, so you could do these like the other ones, but the best way to do 45s is just count from the odds to 7. So you're going to have 1, 3, 5, 7. Okay, easy enough. So that's going to be 1, 3, 5, 7. Okay. So knowing each denominator would be 4, and the numerator can be found by writing consecutive odd numbers counterclockwise around the circle. Okay. Alright, unit circle. So remember when I told you where those x's and y's would come in handy? Now is the best time to really understand how to do that, okay? So let cosine of theta relate to x, the x coordinate, and let sine theta relate to the y coordinate, And tangent is going to be, yes, you've heard me already say this in the other video about 2 or 3 times, the numerator of sine over the numerator of cosine, okay? Because the denominators of both sine and cosine are going to cancel out, as you saw in the other video. So here's a nice little diagram. I did not make this, I got this from the internet, okay? So x, y, so here's your x, so cosine is equivalent to x, and sine is y. So when we do the unit circle, it's going to be cosine, sine, and then we're going to put tangent in there because it's always good to know tangent as well on the side, okay? But we're talking about exact values. So exact values, okay? So this, if you remember, a radian is like 1, so you're starting with 1. So just look at this as a coordinate plane, okay? Before the circle is even there. So if I was to ask you what that point is, you would say 1, 0. Okay? This point is going to be 0, 1. This point's going to be -1, 0. And this point's going to be 0, -1. Okay? So if I were to ask you what cosine of 0 degrees is, because this is the 0 line, cosine of 0 would be 1. Sine of 0 would be, cosine of 0 would be 1. Sine of 0 would be 0. Okay? So, if you know the quadrant, you're going to know the rest. Remember that all angles are symmetric, so the exact values correlate to that as well as the positives and negatives of the quadrant, okay? So remember when we had that like 120 over here, the signs are just going to be different. That's going to be -1/2 square root of 3 over 2, okay? So again, if I were to do cosine of 0 degrees, this is how angles are kind of written. So you're going to have a trig function of an angle is going to give you an exact value. So cosine, you're always going to be looking at the x value, okay? So here we go. All right, so cosine of 0 degrees is going to be 1. Sine of 0 degrees is going to be 0. Tangent of 0 degrees is going to be 0 divided by 1, which is 0. Okay? Okay, so cosine of 30 degrees, remember you're on the x, cosine of 30 degrees is square root of 3 over 2. Sine of 30 degrees is 1/2. Tangent is going to be the numerator of sine over the numerator of cosine. So that's going to be 1 over square root of 3. However, I don't like radicals in the denominator, and other teachers won't either, so you're going to rationalize it. I'm going to rationalize it over here. So 1 over square root of 3 is going to be multiplied by square root of 3 on top and bottom. You're going to get square root of 3 over 3. I went in more detail on the other video on how to rationalize denominators. So if you want a better look, you can go there. So 1 over square root of 3 is square root of 3 over 3. So if I was to ask you what's the tangent of pi over 6, you would say square root of 3 over 3. Here, so cosine of 45 or cosine of pi over 4 is going to be square root of 2 over 2. Sine of 45 degrees or sine of pi over 4 is going to be square root of 2 over 2. Tangent of that angle is going to be square root of 2 over square root of 2, which is 1. Okay, so this is the exact value for cosine at 60 degrees or pi over 3. This is the exact value for sine at 60 degrees or pi over 3. Tangent is going to be the numerator of sine over the numerator of cosine, which gives you square root of 3. And here, so cosine of 90 is going to be 0. Sine of 90 or sine of 9 of pi over 2 is going to be 1. And tangent is going to be 1 over 0, which is going to be an undefined value. Okay? Good to know all these. So here it comes. Oh, If these are tripping you up, okay, all these values have a denominator of 2. Everything like not on the corners has a denominator of 2. So here's how I remember. So everything is like square root. So you got square root of 3, square root of 2, square root of 1, which is 1. And then it goes the other way around, okay? So it goes this way, and then it goes back around that way. Okay? Also, remember, if I asked you what cosecant of pi over 6 is, so what's the reciprocal of cosecant? It's sine. So the cosecant of pi over 6 would be 2 over 1. You're using the reciprocal value here, okay? And here it is, the big unit circle. Okay. So first thing you want to do, you can either do your exact values first, or you can go ahead and do your degrees. I'm going to go ahead and do my degrees first. Okay. So I have 0, 30, 45, and 60, and 90. Okay. Remember, reference angles, 180 minus, these are the theta prime angles you're going to be working on, okay? So this is 180 minus theta prime, okay? So 180 minus 30 is 150. 180 minus 45 is 135. 180 minus 60 is 120. Okay, this is 180. Oh, 4 corners. Here's the 270. Here's 270. Probably should have done the 4 corners first. And this is 360. Okay. Back to reference angles. Quadrant 3 is 180 plus theta prime. Okay. So 180 plus 30 is 210. 180 plus 45 is 225. 180 plus 60 is 240. Okay, over here, it's going to be 360 minus theta prime. So 360 minus 30 is 330. 360 minus 45 is 315. And 360 minus 60 is 300. Another way you can start this is do the 4 corners. And then you can do your 30s. So 30 degrees, 180 minus 30, 180 plus 30, 360 minus 30. Okay, and then repeat with 60 and then go with 45. Or you could do it the way I did. Okay? I'm about to actually do that with the 30s now for radians. Okay, so remember for 30s, everything is pi over 6. The only difference between all of them will be the coefficient in front of the pi. And if you get confused, because sometimes people will get confused between 60 and 30, like some people will want to say 60 is pi over 6 because they see 6. That's not wrong. Just quickly do a conversion from degrees to radians. You'll quickly see that 30 is pi over 6 and 60 would be pi over 3. Okay? So, act like there's not a 0. So this is all the 30s divided by 30. Okay? Or you could just act like that 0 is not there and just do 3 divided by 3, which is 1. 15 divided by 3 is 5. 21 divided by 3 is 7. And 33 divided by 3 is 11. Okay, now we're on 60s. Same thing for 60s. Okay, so you're dividing everything by 60, or you can just take off the 0 there and just do 6 divided by 6. Okay, so 6 divided by 6. Oh, 60 is also everything's pi over 3. So let's write that down. Okay, so 6 divided by 6 is 1. 12 divided by 6 is 2. 24 divided by 6 is 4. And 30 divided by 6 is 5. Now we're on the 45s, so everything's going to be pi over 4. Emphasis on the 4. So pi over 4. Pi over 4. pi over 4, and pi over 4. Okay? 45s, you just count counterclockwise for odds. So this is going to be 1, 3, 5, 7. Okay? Oh, we forgot the radians for the 4 corners. Oopsie. Okay, so the radian for 0 degrees is 0. The radians for 90 degrees is pi over 2, or you could do 90 times pi over 180, so pi over 2. 180 is pi, and 270 is 3 pi over 2. You could also do the division thing with this, because it's going to be pi over 2. So 27 divided by 9 for 90 is 3. Exact values. So let's do our 4 corners first. Okay, so remember, if this was a quadrant, the farthest you can get on all the quadrants is 1. So remember 1. So that point would be 1, 0. Okay, so 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, let's do our tangents. Tangent is numerator of sine over the numerator cosine, or you could just do sine over cosine. Remember, sine correlates to the y coordinate, and x corresponds to the x coordinate. So 0 over 1 is 0. 1 over 0 is undefined. Oh, you can't see anything. That's a problem. Alright. 0 over negative 1 is 0. I'm just going to put it over here because I don't have room. And negative 1 divided by 0 is undefined. Okay? Now we're going to do our exact values. Remember, so everything is 2 here. Everywhere a 2. Anywhere and everywhere there's a 2. Okay? The only difference is one's going to be negative. Some might be negative, some might be positive. They're 2's, not z's. I'm just going fast. Okay? Okay? If you want to, you can do your negatives, but I'm going to wait. Okay? So everything's over 2. So you're going to start right here. So that's going to be square root of 3, square root of 2, and square root of 1, which is 1. Now, go back the other way. So you're going this way, and now that's going to be square root of 3, square root of 2, and square root of 1, which is 1. Okay? Let's just go ahead and go around. So over here, x is negative, y is positive. So everything's symmetrical, okay? So this is going to be negative 1/2. The only difference is the signs are going to change. This is going to be negative 1/2. That's going to be positive square root of 3 over 2. Okay? I have square root of 2 is over 2, so the only difference is the x coordinate is going to be negative. And here, x is going to be square root of 3 over 2, y is going to be 1/2, except the only difference is the x will be negative square root of 3. Okay? Third quadrant, they're both negative. So again, you can just kind of write off this line right here, okay? So that's going to be square root, so this is a 30. So that's going to be negative square root of 3, negative 1. 45, just follow the line down. So this is a 45, so that's square root of 2 over 2. So it's just going to be negative square root of 2 and negative square root of 2. Next one is going to be a 60 corresponding angle. So that's going to be 1 and negative square root of 3. Okay, now we're over here. So symmetric with about this. So this is a 30-degree angle. So see 6 and 6. Same numbers, but just different signs. So x is positive over here and y is negative. So you're going to have positive square root of 3 and negative 1/2. Positive square root of 2 and negative square root of 2. And then positive 1/2 and negative square root of 3. Okay? Last but not least, let's do our tangents. So, some of you are probably still skeptic that these two aren't going to cancel out because you're like, but it's sine over cosine, I got to do it. Okay? So I will do it for you one more time to prove to you that these twos cancel out. Okay? So remember, tangent is sine theta over cosine theta. Okay? So sine here is 1/2 and cosine is square root 3 over 2. Okay? So 1/2 divided by square root 3 over 2. Multiply reciprocal 1/2 times 2 over square root 3. And I feel sympathy for you, so I'm just going to go in and remind you how to rationalize the denominator again. So multiply by square root of 3. Square root of 3. So tangent at the 30-degree angles is going to be either positive square root of 3 or negative square root of 3, depending on the quadrant. If you have the same sign, tangent is going to be positive. If you have opposite sign, tangent is going to be negative. Okay? So this over that is square root of 3 over 3. We have a negative x, positive y, so that's going to be negative square root of 3 over 3. We have a negative x and a negative y, so that's going to be positive square root of 3 over 3. Remember, everything is symmetric. So these are 30-degree angles, so everything corresponding to like a pi over 6 or a 30 in some way will be square root of 3 over 3. Okay? And over here, positive over negative, opposite sign, negative square root of 3 over 3. Okay? For 45s, square root of 2 over square root of 2 is 1. Opposite signs is negative 1. Negative square root of 2 over negative square root of 2 is positive 1. Negative square root of 2 over square root of 2 is negative 1. Okay? So numerator over denominator, square root of 3 over 1 is square root of 3. Square root of 3, so opposite sign, so that's negative. Tangent's negative in the second quadrant. Tangent's positive in the third quadrant, and tangent is negative in the fourth quadrant. Okay? There is your unit circle. Okay? And then you get the graphs, which we will do at another time. Okay? So that's for the unit circle. I hope that was able to help you. So, I want to see you. Okay? So, I hope you had fun. I hope you were able to understand some things. I hope you have a great day. Okay? It's late. I'm about to go to bed. So, good night and sweet dreams.